Hello there, and welcome back to another day where you have some free time. And in this day's video of unstd-c, we'll be trying to implement malloc. So let us get started by, actually declaring the function malloc and, oh no, not free, but size, and actually declaring the function free that will take a pointer. Now, how should we go about this? I guess we can at least try to recreate the behavior of malloc in glibc. That that will give out a chunk of memory, but there will be information before said chunk of memory that will be used by libc. So I guess we can try that. So first gotta include the standard library, and then let's define some structs. So for one, the actual heap data that will be the main storage of our memory that will be giving to the user, and the representation of the memory that we get from the kernel. So this should contain the size information of the heap, well, the size left anyways, and then other structures. That is the actual heap chunk that we give to the user. So let us define that as well. So this one contains the size and maybe, I guess, a pointer to itself as well. That will point to the next chunk and the previous chunk. Oops. Then for the memory that will be returned, well, this will be returned along with it, but the user will only be able to access the later parts of the structure. I guess it will be called something like payload, though no need to define that here. So we can now define these here. So a structure of the heap chunk type, and let's just call that the read ones. And let's also put that in the used section. So maybe that's good. Also, another thing is when we run out of memory, well, we ask more for the operating system, and I guess we can store that here as well. So we'll have multiple linked lists, and it will start out as heap data, call that libc mem. It will start out as null. And when we try to call to malloc, uh, say a size t, and we see that um, libc mem is equal to null, or the, no, let's just make it, if it's null for now, we try to allocate to this. So libc mem is equal to mmap, which reminds me to actually include the header files. So mmap null, and I guess the length, which is, well, let's just make that 4096 bytes or 4 kilobytes. So 4096 plus the overhead, So the heap data over here, let's add that there. Size of libc mem. Then the protections. So I want this to be readable and writable, but I want this to be a private memory along with anonymous, as this is not memory from a file. Then the file descriptor can be -1, the offset be 0. So if libc mem is equal to map failed, then we return null anyways. Though after we set this up, we say libc mem that size, or should be like that, size is equal to 4096. And well, it's gonna be like the one we allocated will be the heap data along with the other mem block that will give out to the user later on. So yeah. And over here we set libc the next one to be null for now, along with the freed ones. No, the free section will be libc mem, but it will be +1, I believe. Or maybe, well, let's try to allocate this. No, cast this to a void pointer for now. Then this as a character pointer. Then we add the size of heap data. Or maybe adding +1 is enough. Since, well, I want the structure to look like the memory we got from the OS, well, the kernel, be the heap data. Then inside that heap data, the freed section will point to the area after the heap data. So after the heap data, which is, I guess, +1. Now the used one, mem used, can be null. Oops. Now for the tricky part, say that we have enough size. Well, no, we gotta find if there's anything in the freed section for now that is enough. So let's set a temporary variable here called the c, and it will point to libc mem read. No, wait. I guess we should also add something else. So while the size is greater than or equal to something, which will have another temporary variable for the heap data, just call that t, and it will point to libc mem. And while the size is greater than the size over here. Then we say d into the next one. And if d is equal to null, no wait, I gotta add something here. So if d is not equal to null, and this one, then we can move this to here and change glibc mem to just d. Well, over here as well. So there's that. So if it encounters, but if it's not enough, then it will go to the next block. And if it's null, then it will go to here first. Now we can have our return variable set to null. And instead of this being libc mem, that should be d. Now we try to find a chunk in here that is enough for the size. Or maybe we try to create a chunk when this part of malloc succeeds. I guess that will do. So if this is the case, then we have size over here be equal to the size of malloc. And then the previous one can be, I wonder what can be the previous one. Because we have the free chunks over here. So how can we go about this? Well, we'll deal with that later. But the next one is easier. Let's make C be a character pointer that will cast later on. That will add the size of C plus the size so that, well, after this, we have C and the actual block of memory. So that will be C plus size. Then I want C next to point to somewhere after this block. So I guess a byte later. So I guess that will do. And then we make this point to, um, no, we gotta cast this to a heap chunk. And then what will actually return will be C plus 1. So return ret. And what else? I guess we can only make the previous one. No, the next one's previous 1.2 C. So let's see what would happen. We'll be leaking memory for now, but might be fine. So instead of mmap over here, let's try to um, use malloc. So standard libh, malloc, I guess 8 bytes. And instead of map failed, we should have null and remove munmap over here and see what would happen. So let's try building this. What do you mean? So writing 1 byte into a region of size 0? No, that's concerning. Wait a second. Well, let's try running it anyways. Huh, I guess malloc succeeded. I guess at exit on the C runtime, well, on this exit version of here, on the standard library, let's have an extern um, what value should we have here? So heap data. So a struct heap data and an extern struct heap data pointer called libc mem. And with this, before actually exiting, well, we got a free libc mem. So let's have pointer to the next one. Cmem next. We'll be just making sure for now that, well, we have something else over here. Well, now that I'm thinking about this may be a bad idea. So I guess I'll leave that there for now without unmapping mmap. And maybe we'll deal with something else. Well, we'll deal with free later on. Though I kind of want to see if B would also work. Make that 9. And actually add more information over here. So make A become B. It should be 9. And I want to add another one. Well, after Croissant anyways. So make that 1. And let's see if we overwrite some memory. If our malloc implementation is wrong. Surprisingly not. So I guess we have a sort of working malloc implementation, though I'm kind of doubting myself. But thank you for sticking with me this far, and may I see you on the next one.